Hey everybody, it's Mrs. Cazell. On to meet the drive distance method in CoderZ. So it's time now to introduce the cs.drive_distance method. This method activates Ruby's built-in P controller. Sweet, all that work I did in the last one apparently is built in for driving a given distance. Once again, your code is cleaner and simpler. Well, that's always good. Know that the drive distance is in centimeters. So if you want to drive 1 meter, you should enter cs.drive_distance, open parenthesis, 100, close parenthesis. Keep it simple. The one line of code is all you need. Just measure and enter the distance. Okay, cool. How do I measure the distance again, you guys? Like, I know that was a thing that was on here. Oh, it's this tool thing. It's this tool thing. Yeah, okay, so I can do this distancing. I click somewhere and I go like this. So the middle of my target is 6. So I'm going 100 centimeters, so I want to go 600 centimeters. Oh, I don't need that down. Lovely. Sweet. Just like the last one did. Okay, that's awesome. So, I would have thought it would let me go on to the next one. Give me a little indicator. I assume we're done. So, turn. So now, Ruby has a 2-motor drive system, meaning each drive wheel has its own motor and can move at its own speed and in its own direction. In this mission, the target is on Ruby's right. Use the cs.set_speed with positive value for the first argument, the left motor, and a negative value for the second argument, the right motor. This should make Ruby turn towards the target. So this is a point turn if she's going positive with one wheel and negative with the other. The idea is imagine axle through her center. She's going to be rotating on either side. Even just like do that with your arms, like pretend you're running and you're going to go that way. You moved one back and the other one forward. We're doing the same thing to rotate around at that center. So small values are good for turning. Turning will continue until I call the brake function. Find just the right amount of sleep needed to turn 90 degrees. Look for the edit here. Comments. Oof. Okay, I gotta get more comfortable, you guys. That's a lot going on. I'm actually going to take a little screenshot of this because those are a lot of things for me to pay attention to. And I did not look at the answer before I started this one, which I told myself I should do as the teacher, but you know what. Okay, so I'm going to start my code here. Oh my gosh, I gotta write the whole thing. Okay, so what's my code look like to make my robot go? So this is going to be set the power. Are we doing set speed or setting power? Does it matter? I wonder if I'm supposed to do speed. Okay, well we can do speed. Okay. So it says apply speed. Okay, so robot.cs.set_speed, and then all right, I want to make Ruby turn to the right, so I'm going to have a positive. I'm going to start small, but not like super small. I'm going to go 50 and then negative 50. So this should make my robot turn to the right. Okay. Wait before braking just enough to get Ruby's turn 90 degrees. Okay, so I think I'm going to have to experiment with this a little bit in order to like really see what happens. They're suggesting 3 seconds. So that's obviously going to depend on my speed, so we better try it. And then it's going to call the brake function after that. And then make sure she skids to a stop. And then we're going to drive ahead full speed. Oh, but we want to go. The target is now ahead of Ruby. How far do you think? Okay, let's measure this. I'm going to flip my camera. Oh, there's a wall? That's super nice of them. Put a little wall there. So, if my point turn is successful, though. Okay, so I want to go 5 meters. It probably said that, and I didn't pay attention. So, really, what would be great is to use, what did it say? The new built-in little For the first recommendation. I don't want to delete my code. Can I hear the hints again? No, I don't want to reset that. I want you to give me the directions one more time. Okay. So this is a great example in here. I don't know how many of you have experienced this, but like I don't want to restart the mission because I don't want to lose all my code. And then I can copy and paste it, which is probably what I'm going to do right here. But I need to take better notes when I do this. So, oh, never mind. I thought they gave me a different hint in there. Okay. Maybe they did on the last mission, and that's what it was. All right, there we go. So there's my codes. So I want to go. I want to drive a specific distance. This is set. Is there a set distance? It doesn't look like there is because it's doesn't call it up as an option for me. 5. Is that what I did on the last one? I think it is. It's just set distance. I don't need a space right there. Let's see what happens here. Okay, so I'm probably gonna drive up the board. All right, let's run it. Oh my gosh. All right, yeah, 50 is way too powerful. And then yeah, that'd be not going anywhere. So I'm actually gonna go back to the previous activity because I want to look at that bit that it's drive distance. Okay, so I need so it's not set distance, it's drive distance. Okay, so that makes sense. Okay, so let's go ahead and do this again. I did copy and paste my code. So I'm going to go ahead and delete this and paste my code that I've got. 50 is really too long though, so I'm going to go down to 20. And we're going to start by going just 1 second at a time. I feel like there's a way I should be able to measure this and know what my alignment is without eyeballing it. But yeah, but I'm not entirely sure. So, oh, drive. There we go. Oops. That's the function I was looking for. I want to go. Oh, but they said it's in centimeters, right? Okay. So that is in centimeters. All right. So let's go ahead and try it. Let's see what happens. Okay, so I'm going to turn. Ooh, still too far. The speed was pretty good, though, for a pretty accurate turn. Hey, babe, come back. Okay, good job, Ruby. Okay, so it's not your fault, honey. Okay, so 1 second. This is where in class we would actually measure this. We would do a lab to figure out, based on your wheel radius, what do you have in terms of turning power. Oh, that wasn't bad. So 10. 8. Okay. So really low speeds is good for turning. And that was not horrible. I only had to wait 1 second. So it really wasn't that bad. Okay. So that makes a lot of sense. I'm going to go on and do the next one. Gyro's turn. Oh, this is what I was talking about. Like I should be able to know my angle, right? Okay. So Ruby's API allows us to use the HUD and view the gyro sensor value. Oh, duh! I looked at it a second ago when I was trying to find the measuring tool. Activate the HUD and expand the gyroscope display to view the readings. Turn Ruby towards the ramp. Y indicates Ruby's rotation. Note the value when Ruby reaches the desired angle facing the ramp. So I would guess it should be 90 degrees. Time to get rid of the time.sleep and execute the break command based on the gyro's reading. Okay, hence speed matters for every turn. Yeah, I like 10. I'm going to go back to 10. Allow stopping time when entering the value of the angle. And look for the edit here comments. Okay, I think I got that. So, yeah, where did I do the HUD? It was up here. This is the HUD. Gyroscope. Okay. So sweet. Okay, so I'm gonna hang on, come back here. I'm gonna set up my robot.cs.set underscore speed. Yeah, this is, whoa. I'm going to do a point turn. So my values need to be equal in opposite directions. Anything else ends up being a turn with a radius greater than 0. Wait until the gyro y hits some degrees, which, should be 90, right? With the braking. Okay, I've got to include think about the braking time. Okay. So yeah, so here's where they're going to apply the brake, and they've got this little wait time, but I'm going to get rid of that, right? Or no, there was the time in the last one that I got rid of. Okay, so the angle, do I put a number in there? Distance should bring Ruby to 90 degrees. Okay, this was a question mark here. I'm mucking around with things and I'm not thinking. With the braking distance, it should bring Ruby to 90 degrees. Well, the robot gyro is less than 10. Don't exit the loop. I think this should be 90, right? Okay, well, okay, here, hang on. Let's do what I did before, which is I'm going to test it with what I've got, right? I know that what I have here, I'm just going to look at the turn too, not the forward drive. Ooh, okay, so, and what did it do? Okay, it went 31 degrees. That surpriseth me. So, it's going to fetch that angle, and that's what's happening? Is that, am I assuming? Okay, I'm just going to go by increments of 10. So when it was 10, I had 31 degrees as my angle. This time I had 38. Interesting. Gyroscope, they were at 67. I feel like that's really inconsistent. So, okay, let's go back and let's put it at 90 because that's what I want to do. So let's just see what the brake does. Okay, so the brake adds, whoa, 24 degrees on there. That's pretty amazing. So let's try sending it just 65 degrees and see what happens. That looks lined up pretty good. 86 degrees. All right, so the question I have going through this is, so far I'm just guessing and checking, right? So I don't want to do that as my coding strategy. I mean, obviously experimentation is important. You got to know how your machine works. See, like that's too far. 93. So yep, I can just need to add one more degree of 66. All right, now I'll turn the gyro on first. I'm going for super accurate. Probably I wouldn't be able to make it to my target otherwise. So 93. So we've got enough variety in however they factor in the bit of random in the real engine here that it means I didn't make it all the way. That is maddening. There's an 8-point differential there. So how accurate is this thing? Is my number block on? It is. Okay. Let's. Okay, well that's exactly 90 degrees. So, but that's the question there is like the guess and check. How reasonable is that to want to do that? Okay, and now I know it's 5 meters, so I'm going to use that drive distance function. I always type, I know you can autocomplete some of those things. It's in centimeters. but I find it's great practice to always type your code. All right, so we're going to execute that turn, wait for a little bit to make sure we're forward. Okay, cool. So the thing that I want to know is I'm going to look at my tools, and you know, that's the piece I'm not sure about is like, you know, I just guessed that number because the brake is a little out of my control. So I wish I didn't have to do that. So, all right, that's Gyro's turn. Turn on the controller. Last mission, we eliminated the need for guessing the right amount of delay for turning, but still we needed to guess the gyro value. I got ahead of myself here. But still, we needed to guess the gyro value to begin braking. This time we'd like to use the same algorithm we used for drive distance, a P controller, so we won't be dependent on uncontrolled braking distance. This is your second encounter with a P controller. Some initial code will be given here, but you'll need to complete it. Shoot, this will be a test of if I learned anything. Okay, I learned last time I need to look for hidden things in there. So my desired angle, yeah, I want to turn 90 degrees. So while this is true, I'm going to be every 0.01 seconds is my iterations here. So I'm going to get the gyro Y readings because that's my, let me turn on my HUD so I can see that. Okay. So I'm going to calculate the error to the destination. Angle that's left, and that's like before where it actually means the remaining angle. This is where I'm going to have like my desired angle minus I don't know, how do I fetch my angle? Alright, well I declared a variable there, but I don't have that up there anywhere. I don't know how to get gyro Y readings. Alright, so I already know this isn't going to work because there's something that I don't understand. So let's go ahead though and we'll work through the rest of the code and then we'll come back and we'll fix this. Alright. That's funny. Tried to edit my comment. Set speed to be proportional to the angle that remains within reasonable bounds. So my proportional controller, I'm going really slow. I don't have a good handle for what this proportionality, what makes this useful. So, because I got such tiny speeds, right? So I got my angle that's left is going to be hopefully a really tiny decimal, varying between 10 and 10. I'm glad that that's the number that they picked because that's the number I picked before. I can't blow it up, so let's try it out. And hang on, this rate, okay, so it's got the set the speed to those two things for the turn. Comment this line to see how your speed is going. Yeah, I totally want to do that. Okay, if the speed is low enough, it'll do this thing. Alright, I'm just going to worry about the turn for right now. I'll lock this in, the other camera view. See my gyro right there. Let's see what happens. I'm going to guess nothing because I'm not fetching my gyro angles. like I thought. Yeah, see, because I made up this like current angle thing, and it's obviously doing nothing. So, all right, so let's go ahead and reload that. And then how do I get gyro reading? So I skipped any other previous lesson that used that. So I'm going to copy my code so I can paste this. And I need to go back and find... Oh, there's a baby crying. I feel like I need, like in SpongeBob, the 1 week later, you know, the thing like that. So, okay, before I get crazy and I go back to another lesson, I want to go see if in our collected knowledge we've added any of the gyro information. We haven't yet. Okay, so we need to revisit this. This is a useful document, guys, so you did a good job making it. So I actually need to go back to the Learning Center, I think. So this one, oh, is this where I am right now? No, I'm on turn on the controller. So yeah, I didn't pay attention in the code here. All right, here it is. Okay, yeah, go away, little. I got it. Here it is. So this is my new function, robot.gyro.getAngleY. Okay, so that's the code that I need to use there. Get angle y, and then I tell it if it's less than some number of degrees, right? So that's what I'm fetching for the next part there. Okay, so let me go ahead and go to this one, right? Is this the one I'm on? Yeah, okay, so I'm going to go ahead and update the little bits that I did. So yeah, instead of this, I want there to be a new variable for this like current angle. So I'm going to add it up here. I don't know why I'd add it anywhere else. So I'm just going to add this here. We'll see if it's a good place for this. Yeah, so read current gyro. Okay, and I called it current. Oops. Oh, I can type angle, and that's equal to this robot. Oh wait, do I want to do it the other way around? Well, here, let's learn something. Set. Oh no. Get gyro y. All right, and then it had this, and then it was when it was less than some number. So okay, I'm gonna run it. Let's see what happens now. Nope, I got nothing. Okay. So that clearly is not how it's supposed to work. So, okay, well, we'll go back and we'll change what we're doing here, which was that I was saying instead I need to call my function first. Robot.cs dot get gyro one. Am I not doing it right? That's a distinct possibility. Why am I putting this here? Okay, so I'm just gonna comment this out because I feel like this should work, but it's not. So I'm just gonna comment that out. I'm gonna type that function over here. I don't understand a lot about any of the syntax rule, or not any, but a lot of the syntax rules. See, oh wow, it appears right here. Interesting. It didn't let me call it right there. I wonder what that is. Alright, so I just want that number. is what I want. That's why I was adding the stuff in here. So this doesn't make sense. You're right. Yeah. Okay. So I don't need this. Yeah. Just get rid of that. Okay. So now this should work for my turn. Okay. So what I'm gonna do is I want to figure out what's going on down here. So instead of having it print my desired speed, I'm going to have it print the angle left so I can see what's happening. -90 minus. Yeah, does it have axes on already? It doesn't, so I am just assuming that that's my z direction and everything. Okay, let's go ahead and see what happens. Oh, I get nothing to print. Okay, that's good to know. So that means I'm never reaching this point in my code. So something's not working. All right, because it's 11 o'clock at night, I'm going to look at the answer because I can. Go ahead and copy my code right here. So let's figure out what mistake I'm making. Oh, I've got a CS in there. So it's just I'm not using the right snippet of code. I'm not actually executing the right command. So, wow, if there's any more proof that I need to actually take notes in here, because without a lot more practice time, I'm not going to have the opportunity to make the memory to get this right. So, okay. Oh no, I just copied the code that was used. I'm going to do this again. Man. All right, so it's, what did I say? It's this desired angle minus, and here's where it was different. It was robot dot gyro dot get. Oh my gosh, did I not understand what it is? Okay, so this is like the worst, you guys. Robot.gyro.get angle y. Okay. Oh, my code was there for a second. I'm gonna reload it. Okay. All right, angle left. So that's my current or desired angle. Sorry, that's what it's called. Desired angle. Robot.gyro.get angle. Okay. Okay, I'm just gonna execute the turn. Hey, we're wiggling. We're making progress. Okay. Oh, I forgot to change my angle is why. Okay, so alright, so let's go ahead and reset this and run this again. Okay, we did pretty good. And we turned. Now, so the program still goes. Okay. So that's awesome. Okay, so that worked. Oh, whoa. Did I wiggle out of range? Did you see that? I blipped like way over. Okay. Um, Interesting. So my proportionality is in degrees now, right? So, so this proportional controller, the idea of calling it like 100 or something or 50, using any of the proportional experience I had before, it doesn't make a lot of sense. Let's go ahead and make it like 5. See how that works for my wobble. Pretty small and pretty good. Okay, so now I need to make it go forward. So if the desired speed, where is desired speed? Uh, is less than 0, it says stop. So we get to wait a nice amount of time. And now we want to drive forward, right? So we're going to do robot dot set speed. No, drive distance, drive distance. Yeah, 500 centimeters. At least they reuse the same track idea for a while. Let's try this again. It goes over. It's going to come to a stop. When it's in position, it should brake. Ooh, there we go. I didn't like how that executed at the end there. How come it was so slow down the ramp there? I mean, it made it, but it sure seemed like it cooked along on the last one. So, okay, well, there we go. I guess I got it. I'm gonna go ahead and call this one here because this is already a 30-minute video. So, thanks guys for watching. Keep learning.